afternoon, everybody. We start today with our supplier management lecture, 30th of September. And today we're going to look at some models already getting into more detail. We're going to look at the economic order quantity models. In this lecture, I will only have time for the theory. I will upload later on a PDF with some exercises. Please make sure you look at them. In the GitHub, you will have the exercises, okay? So first of all, we are going to define some parameters. This is going to be maybe some difficult lecture for those of you not very comfortable with math. Olena, please try to be on time. On time means 30 seconds before we start, okay? No problem. So the first thing is the demand, which is measuring parts per time unit. The second thing is C, which is a cost per unit. And this is going to be measured in euros per part. And then also the setup cost, which is the cost it takes to change from one product to the next, euros. And also this is A, and then H, which is going to be the inventory holding cost, which is going to be measured by euros per time per part per time unit. So the more we hold the inventory in our books, the more H increases. And those are the parameters that we're going to be using in the three different models that we see today. The economic order quantity model has different variations, so we were going to see three of them. The first one is the EOQ, economic order quantity 1. Okay, this is our first approximation. It's the easiest. And we have the hypothesis that that we have immediate delivery and production. So this is something ideal, okay? And also we have a constant demand. As you can imagine, this has nothing to do with reality, but we take it like our two hypotheses, okay? So we have our curve. This is the time. And this is the inventory level, okay? And our order quantity is going to be something like this. Let me take this color. So this is going to be our order quantity. Q. And our demand is going to be like this, because we have immediate, so this is T0, and this is, let's say, T1, because we have immediate delivery. In T0, we have full order quantity. And because we have constant demand, there is a line that goes down constantly and depletes the inventory to 0 in T1. And because we have, again, a perfect delivery, let's say immediate delivery, we go immediately to Q1, to, in T1, we go immediately to Q, to our order quantity. We order certain set of parts and so on, okay? So this is just this, if you wish. This line is vertical. This line is vertical because it takes no time to deliver Q units, okay? Hence, immediate delivery. Okay, and also this line has constant slope because constant demand. Okay, so this is our model. So we are looking for the best economic order quantity, and so we can say that the time between T0 and T1 is Q divided by the delivery. If we say, we can call this the frequency. Of delivery. And if we take Q is measured in parts, and the demand is measured in parts per time, we get time units, because parts goes with parts and time goes up. Okay, so any questions so far? What we're looking with the economic order quantity is to get the best order quantity to reduce our cost. So we need to define a cost function. And the cost function is going to be y, in German epsilon, and it's going to take the cost of inventory, how much it costs to carry the inventory, plus how much it costs to change from one part to the next, the setup cost, plus the production cost. As you see, this is very logical. Okay, so how much is the cost of inventory? If we have the inventory holding cost and we multiply it by the average cost, by the average inventory, then we have the cost of inventory. So we have H, which is the holding cost per unit, and we have our average inventory, which is Q divided by 2, because we have this line, remember the constant demand, so in the middle is our average inventory. Okay, so I am going to change here the color and say this is our average inventory. So average inventory, Q divided by 2. Okay, so this is our average inventory. If we continue with our formula, the setup cost we can calculate by taking the setup cost per unit. Okay. setup cost and multiply it by the frequency of setup, how often it happens, okay? Q divided by D. This is the frequency, okay? Frequency of setup. How often we go, it repeats T1, T0, okay? How many times we have there. How many times we go up and down in this saw, okay? And the last thing is C times D. C, remember, is a cost per unit, and if you multiply the cost per unit by the demand, you get cost per unit, and D is the demand, so you get the production cost. Okay, so this is our cost function. Let me paint it for you. Okay. Let's do some painting here. And this, if we represent Q, we want the economic order quantity, so the best Q to reduce the cost. We want to find the minimum of this function. Now imagine we represent the production cost. This is a constant. It doesn't depend on Q, so this is a constant. So this can be represented as a line, okay? This is a production cost. C times D. Then let's say the setup cost. Well, the setup cost is a function that is going to be A times D divided by Q, so something like this as a function of Q, or something like this, I don't know. Okay, so this is the setup cost. This is A times D divided by Q. And you can also have the cost of inventory, which is a function of Q, so a line going up, because H is positive. Something like this, okay? So this is the cost of inventory, HQ divided by 2, okay? So what we want to, we need to add up all these three curves. So we get something like this, okay? With a minimum. This minimum is going to be exactly here, where the two lines here intersect, okay? So, like this. And this is our economic order quantity. And this is our optimum cost at the economic order quantity. So Q star is the economic order quantity, 1, and Y of Q star is our cost by economic order quantity 1. Okay? Any questions? So do not hesitate to ask, okay? So how do we get the minimum of a curve, of one variable curve? Somebody tell me? Hello? How do I calculate the minimum of a one variable curve? Ja, auf Deutsch. Yeah, yeah, exactly. We need to find the first derivative of the function on the variable q, and then put it q equals q star, and then make it 0. This way we find q star, okay, the minimum of a function. Okay, so if we make the first derivative of h divided hq, so the function is hq divided by 2 plus ad divided by q plus cd, where q equals q star equals 0. So the first derivative is of hq divided by 2 is h divided by 2, okay, minus ad divided by q star square. Jill, please make sure you are on time, okay? Next time. Okay, make sure next time you're on time. So Q1, and then we go here on Q1 star, and we can find the solution to the problem, 2AD divided by H. Okay, and this is the Q star by this model. Okay, if we substitute the value on the function that we just described, then we get Q star 1 divided by 2 plus AD divided by Q1 star plus CD. Okay, here we're going to make an approximation. We're going to make CD equals 0 as approximation. It doesn't change the model, just to make the formula easier. Then we get that H times 2AD divided by H in square root divided by 2 plus AD divided by 2AD divided by H equals the cost at the economic order quantity 1. And this means we get, if you do the calculations, you get 2ADH. Okay, so this is our cost at the economic order quantity 1. These two results are interesting and important because we have analytically solved this equation. Okay. For the exam, you need to know not only the results, you need to know also the whole derivation of the formulas. Okay? So, any questions, please? No questions? I assume it's not good that you don't have questions. You can also ask in German, okay? I repeat, you not only need the results, you need to also know how we get to the results. Okay, so I can ask you also the theory in the exam. Yeah, sure, no problem at all. Yeah, no problem at all. You can ask anytime. Make sure you make comments into the YouTube channel, okay? And this help you. You help me help you, okay? So let me know if you have questions anytime, okay? Yeah. Yeah, second semester is a long time ago, I guess. And this is more analytical approach, I think, than what you saw. So maybe you want to look at the notes from second semester. So the second model is called the supplier model. Remember, we are in a supplier management lecture, so this is why I am advancing a little bit more than just the basic. This is the basic model, economic order quantity, the one you will find in almost any book. What I'm going to give you is a little bit more. So the hypotheses are expanded here. Here we accept stock out in which supply has a backlog of orders. And of course, this needs to be modeled and to have a backlog costs money. Then you have also delivery and production are immediate. This is also not true in reality, but this is just the intermediate model. Here also demand is constant. Okay, so the parameters here are a little bit more than before. Remember those we had, those stay, but we also have P as cost per not supplied orders. Measured in euros per unit or euros per part. And S is the inventory after delivery. Okay? Measured also in parts, in units. So that Q minus S equals the backlog. Okay, Q is the order quantity. So if you have a backlog and subtract, or if you have an order quantity and you subtract the inventory after delivery, you have the backlog, what you were missing. So let me describe this again in a picture, which makes things, I think, easier to understand. And to picture things means that we have them under control. So let me show you the picture, how it looks like. We again have here our time, okay? T is time. And then we also have our vertical level of inventory. Okay, and then we have our inventory after delivery. Again, here this is S. Okay, this is the inventory after delivery. And then we have the backlog, which is the amount of inventory that we go into minus. Okay, so we go the backlog there. This is the backlog. Is the backlog, and this is our delivery, which is immediate because production is immediate. This distance, let's say, let me put it like this. This is our delivery queue. Okay. So again, let me comment. This line is vertical. Because production and supply are immediate. This line has constant slope because demand is constant. So the way it happens is that you have an inventory after delivery. You start consuming your inventory, you go into the backlog, and then at some point you get a delivery of Q, and then it goes on and on all the time like this. Okay? So this is basically the way it works. All the time. So T0, sorry, this is T0 and this is T1, okay? And T1 is, as you can imagine, T1 equals S divided by D, okay? And wait. Let me do it right. This is T1 and this is T2. T1 is S divided by D, which is nothing but S divided by the slope, okay? Which is the demand. And T2 is equals Q divided by D. Okay, which is Q divided by the slope again. So with this information, we can go and define our cost function. So let me paint it maybe better. This triangle here, within this triangle, you will have your inventory running. And here in this triangle, you will be in a backlog, okay? So which one, can you tell me the average inventory, please? What is the average inventory? Yeah, so what is the value? Before we had Q divided by 2. So the height of the triangle divided by 2. And now we have what? What is the height of this triangle? No, because the backlog, you don't have inventory. You have only orders. So the average inventory is S divided by 2. Okay? Because the backlog, you don't have inventory. It's in the middle of the purple triangle, okay? So let's see the cost function. Now it's a function that depends on two variables, Q and S, okay? And as we had before, we have inventory holding cost. You also have backlog cost, because it takes money to hold the inventory. It takes money if your customer is not being supplied. You have also setup cost, and you also have production cost. Okay, so let's look at each one of them. Holding inventory cost is very similar to before. We have H, which is the holding cost per unit. We have the average inventory. We have the time to consume the inventory, which is S divided by D. And we have the frequency, D divided by Q. How often? Okay. So this is the inventory holding cost. Plus the backlog cost. Is the average backlog. Again, somewhere here. Okay. Average backlog, P Q minus S divided by 2. Or let's say, let me put it in different. P which we said it was the backlog cost per unit, times Q minus S divided by 2, which is the average backlog, times how often, the frequency, okay, and this is the backlog cost. Plus setup cost, which is the same as before, AD divided by Q, plus production cost, CD, okay, so these are the same. Setup cost and production cost. So now the question is, how do we get the economic order quantity and the optimum inventory after delivery? Okay, so we ask ourselves the question, which is the economic order quantity Q start 2 and the optimum inventory after delivery S star 2. For that we equal 0 both first partial derivatives of the function, because the function has two variables. We need to do a partial derivative of the function depending on two variables. And put them equal to 0. Okay. So let's do this. Y of QS equals, if we comprise a little bit, h s squared divided by 2q plus p q minus s squared divided by 2q plus ad divided by q plus cd. Okay. So let's do the variables. The first derivative of qs to q with q star and s star equals minus h s square star divided by q star square plus p q star minus s star divided by q star minus p q star minus s star square divided by 2q star square minus ad q star square equals 0. And the second function, the second derivative regarding to the other variable equal h s star divided by q star minus p q star minus s star divided by q star equals 0. If you solve these equations, we get to the solution that S star equals 2AD divided by H times square of P divided by P plus H, meaning that this equals the minimum inventory, or the inventory after delivery is Q1 star P plus H. And the optimal quantum, the optimal order quantity, sorry, is again 2AD divided by H, P plus H divided by P, meaning this is the economic order quantity, P plus H divided by P, okay? Which is always bigger or equal than Q1. And this is always smaller or equal than Q1 star, okay? When H equals 0, what is the meaning of H equals 0? If it doesn't cost, if H was the holding inventory cost, okay? So how much it costs to retain inventory. If it doesn't cost any money to retain inventory, so if H equals 0, then you have that the two quantities are equal in both models, okay? This is also an important insight. So, any questions? Basically, what we did here is we described two variable function, which has these two parameters. And this function is something like a parabola, okay, and has a minimum. And this minimum is represented with a S star and Q star, okay? I mean, this is calculus, this is not the focus here. I assume that you're already familiar with all this. If not, just raise your hand and let me know, okay? Again, questions? I can repeat any step as you wish. Hello? Okay. Well, make sure you ask the questions, because this thing I am going to ask for sure in the exam. Okay? So, ich werde mit Sicherheit über diese Vorlesung in der Prüfung abfragen. These are points in the exam. Okay? So if you don't ask, you lose the points if you don't understand it. Make sure you ask. And I'm here to solve your questions. I'm not here to look smart, okay? Good. The third economic order quantity model is the most difficult. So this was intermediate. This is called the manufacturing model. Okay? Without backlog. We can make it more difficult with backlog, but we make it without backlog because otherwise it's just too much. Remember, we have the supplier model and we have the easy model. So let's say, okay, the first model is just the basic. And we have the, now we have the manufacturing model. The first one is the let's say, general model we have, and then the supply model, and then the manufacturing model. And what are the hypotheses? And this is important that you remember the hypothesis, because this is what you need to explain when you, if I ask you to put this into the exam, okay, you need to explain what are you, so here we have also constant demand. This is the same for all the models. Here we have no backlog. And here, important, production and delivery are not immediate. Remember, I wrote here a sentence. This line is vertical because production and supply are immediate. This line, okay? And here again, also. This line is vertical because production, because it takes no time to deliver, blah, 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 okay? So, and that's why the line is vertical. So now the line is not going to be vertical. And now we have a different thing, a little bit more difficult to represent with math, okay? So these are our hypotheses, and the parameter we're going to use is the production rate. K is going to be the production rate. So how fast we can produce, okay? It's going to be the slope of the... So let me paint the lines for you. So this is time. And this is the inventory. Okay. This is the order quantity. And what we have is something like this. We produce some rate and we consume at some rate. And then when we get to the... So here we are delivering parts, but we are also consuming them. And the line is not vertical because we don't produce immediately, okay? So here we are consuming. Here we produce. line not vertical because not immediate. And here we consume, the inventory goes down, okay? Until we reach 0, and then it continues the same way, okay? We produce, and we consume, and all the time the same, okay? So the production cost or the cost function is going to be the holding cost of inventory plus setup cost, it's always the same logic, plus, remember we have no backlog, that's why we don't have the backlog cost here, so we go and say the holding cost of inventory is H. And now, what is the average? So H is the what was H? It was the inventory holding cost. Okay, so euros per part time. H is the inventory holding cost. And now the average inventory. So it's not going to be Q divided by 2 because we have different rates. So we have here something like this, D divided by K. So this is the average inventory. Okay. So this is going to be this part plus the setup cost, AD divided by Q, this is the same, plus C times D, this is also the same. Setup cost and production cost. Okay. So we want to find the minimum. Q star equals 0. So what we get is H Q star divided by 2, 1 minus D divided by K, plus, or I guess minus, AD divided by Q star square equals 0. And this means that our Q3, I guess, Q3, if we get Q3 solved, Q3 star solved, we get something like 2AD divided by H1 minus D divided by K. Okay, and this is our solution. Note that if the production rate, the speed of production, is infinite, okay, so if K is much bigger than the demand, then 1 minus D divided by K is almost 1, and then Q3 star is equal Q1 star. We have the first case. Okay? So what is the optimum cost of, in this case? So now we need to replace in the formula Q star, in this formula here, Q start 3. So we go and we say H times Q3 star divided by 2 times 1 minus D divided by K plus AD Q3 star plus CD. We make this 0 for clarity of the formula. So this equals, now I substitute this value in this value and in this value, okay? And so we have H divided by 2, 1 minus D divided by K times 2AD divided by H 1 minus D divided by K plus AD times 1 divided by 2AD divided by H 1 minus D divided by K equal H divided by 2 2AD 1 minus D divided by K square divided by H 1 minus D divided by K plus square of A square D square H 1 minus D divided by K. Sorry. 1 minus D divided by K divided 2AD and this turns out to be the final solution. If we simplify a little bit, we get that the solution is 2ADH multiplied by 1 minus D divided by K. So again, same reasoning. If production rate is much faster than demand, then K is much bigger than D, then D divided by K, or 1 minus D divided by K, is almost 1. As a result, the optimum cost is almost the same as in the first model. Conclusion. Something that you already might know. The more flexible the production, so the bigger K is, the better we can adapt to demand changes. Okay? And this is something logical, and that's why we do Kanban and we do setup control and so on and so forth. Okay. So any questions?